No,
with the recording.
it's okay, fine. But important thing that is I miss that. Okay, no problem. Yes. Okay. So this Dr. Gayatri Doctor is working with the SAPT University as a senior associate professor. Her area of research are mainly this urban management using this technology from the technology perspective. Her other area of interests are like smart cities, e-governance, data-driven urban service operations, open data, and emerging technology for the future cities. I welcome you, Dr. Gayatri Doctor, to this icSoftComp 2023 first technical session. Second session chair is Dr. Sonal Jain. She is working with the SPU, Vidyanagar, as a professor in Department of Computer Science. Her research interests are artificial intelligence, machine learning, and technology for the education. I welcome you both the session chairs and hand over this session to you to carry on this first technical session. You may unmute your microphone.
Yeah. Good morning, everybody. Good morning, Dr. Jain and Mr. Castillo and Patel. I assume we can start. I can see the agenda. We have 5 papers and we have 1 hour.
Yes.
So about 10 to 12 minutes per paper for the presentation.
Right.
So, Dr. Jain, maybe you would like to start off?
Sure, ma'am. Thank you and glad to meet you all. And we are very glad enough to chair the first technical session of this particular conference. Not wasting without much time. Let me invite the first authors of the first paper to present their paper. So title of the paper, ID of the paper is 117 and title of the paper is Multimodal Transfer Learning for Real-Time Fake News Detection on Social Media. May I have authors here, please? Are they here?
Hello. Hello. Am I audible, ma'am?
Yes, you're audible.
Hello. Sir, I cannot share my screen.
Let me make you the presenter, then you will share. Just a minute.
Okay. Okay.
So, ma'am, I will keep track of timings and post 10 minutes, I'll give one signal to the presenters.
You are now presenter, so you can share your presentation and you can start your presentation.
Sir, still it is not enabled.
You are presenter.
The share option
Sir,
is right at the top.
yes, it is there, but I cannot click on it. I'm not able to click on it. Can I leave and rejoin again?
In that case, can we have second author in that? Okay. So
Yeah, that would
title
be
yes.
Move ahead with the second author. Yes.
Hello?
Yes. Hello.
Ma'am, the sharing button is disabled.
Patel sir, we could see it as an enabled one. So is there any difference? Paper ID 124 and title is Classification of Exaggerated News Headlines.
Is that Shri Ram Kathar or who is that?
I'm here. Good morning.
Who is the author? Sudha Patel is also there.
Yes, ma'am, but still share screen is not visible to me. It
Okay,
is still
you are
disabled.
author of paper, first paper.
Yeah, yes.
So you just need to wait. Let us handle second author.
I'm
Authors of
gonna
this
try
paper
to
ID
see.
124.
I'm here. Can you hear me? Hello?
We can.
Ma'am, I can
Yes,
share. Ma'am, I can share. Can I start?
Yes, you shall. Authors of second paper, now please wait for a few minutes. Let her present.
no problem.
Ma'am, my screen is visible to you?
Yes, it is visible, but we can see a mailbox and not the presentation. You'll have to switch your screen. We can see your Gmail box.
Yes, ma'am. Just a minute.
Other authors are
Ma'am, now it
requested
is
to please
visible.
keep your presentations ready. No, yet
Ma'am,
not.
is it visible screen? Not yet.
No, it is now.
Ma'am,
It's
it is
gone.
visible?
No.
No, now it's gone. You close the window or whatever. Yeah.
It is now. Again,
Now
it
it's
is
visible. Yeah. Please
Visible,
start.
ma'am? Okay.
Yeah.
Yes.
Okay. Good morning, ma'am. Good morning, sir. My topic for the presentation is multimodal transfer learning for the real-time fake news detection on the social media. Right now, I'm pursuing my PhD from the Kadi Sarva Vishwavidyalaya. As a research scholar, I'm presenting this particular paper. The outline for the paper is the open challenges, proposed architecture, implementation results, comparative analysis, and the conclusion. Before starting the proposed methodology, we should just throw some light on the existing methodology. So as we know that on the social media platform have become right now a crucial channel for the rapid dissemination of the news in the various formats like text, images, audio, and the videos. uh, for ensuring the authenticity of the news content at the primary state is now crucial to prevent the spread of the false information. So in order to gather the semantic and the contextual data for the identification of the false news, current state of the art majorly concentrate on the text based techniques by leveraging the pre-trained word embedding and the language models. So some of the open challenges we are going to discuss here. The first open challenge is the multimodal integration. As the integration of the multiple modalities like written content, visuals, and the videos poses significant challenges in the multimodal fake news detection. Real-time detection in order to slow the distribution of the fake news or the fake information quickly on the social media sites. This is also we can consider as one of the challenge. Next is the transfer learning in the multimodal context. In that case, the transfer learning techniques have shown some promising results in the various domains, like including the image, including the text analysis, or the we can consider as a video. Okay, so however, applying this particular transfer learning effectively in the multimodal context for the fake news detection is still remain the challenge. The next one is the labeled data, or we can say that the limited label data. So if or we are obtaining the large scale label data set specifically for the multimodal fake news identification is very exciting due to the complications, or we can say that the unlabeled news articles. This also we can consider as the open challenge for this fake news detection. The next challenge is the contextual understanding. What is the contextual understanding? Actually, understanding the complex contextual relationship in the fake news detection is still the challenging task. So, incorporating contextual information such as temporal, social, cultural, along with the multimodal features, can expand the accuracy of the fake news detection. Ma'am, am I audible?
Yes.
Okay. The next is to we can say that to go through this open challenges, we have proposed one methodology, that is multimodal transfer learning for the real time fake news detection. In that, just go through the proposed architecture. The architecture in this particular proposed architecture includes the several blocks and the modules to enhance the effectiveness. The components are like a data pre-processing block, feature extraction in which multimodal, and the next is the real-time processing monitoring. If we are discussing from the first is the data pre-processing block. So for normalizing and transforming the input data, text encoding, image encoding, and video encoding modules to capture the relevant features from the different modalities like text, image, and the videos. If you are talking about the text encoding, so it plays a crucial role in capturing the semantic as well as the contextual information from the textual content of the news article. In that we can use the word embedding technique like word to vec, the transform based model like BERT, ROPERT, like that. Next is the image encoding method. So in that we focusing on the encoding of the visual features extracted from the images, which is associated with the news article only, to extract this visual patterns and the characteristics. It makes use to put in the deep learning technique like CNN. The next is the video encoding technique, or the module. So what is actually the video encoding? So this particular module handles the video data, or we can say that the encoding video data, extracting the informative features from the temporal dynamics and or the modern or we can say that the motion of the patterns within the videos. So this particular data pre-processing block is going to perform the encoding from the text, from the image, and from the video. The next method or the next block for this particular architecture is feature extraction, in which the multimodal fusion and transfer learning is going to perform. So first of all, we are going to discuss the multimodal fusion. So what it is, multimodal fusion is, it is in this particular proposed architecture, it plays the again, it is also the crucial role in the integrating the encoded feature from the different modalities. It combines the textual, visual, and the temporal representations obtained from the feature extraction module. The methods are like early fusion and the late fusion. What happened in the early fusion, in which characteristics from the each mode are concatenated or the joined at early stage. And late fusion, that means what, that it in which the features are mixed later, as during we can say that the categorization. So this is about the multimodal fusion that integrates the encoded features. After that, the portion we are going to perform is the transfer learning. What is the meaning of the transfer learning? Transfer learning in this particular proposed architecture, it exploits the power of the transfer learning techniques to expand the effectiveness of the model for the detection of the false news or the fake news from the social media. So it uses the models, or we can say that the embeddings techniques that have been trained or the other model like a BERT or the robot model we can use. So by utilizing these particular pre-trained models, the transfer learning model captures the rich contextual information and the semantic representation. So after that, the real-time processing and the monitoring is there, which is focusing on the handling the real-time data to ensuring the timely and efficient processing. So again, in having that classification block and the real time processing module is there. What is classification block is actually it extracted from the previous stages and perform the final classification of the news article into categories like fake or the genuine. And real time processing, what it is, focus on the real time data, and it includes the management of the incoming data stream, performing the parallel processing techniques to ensure the efficient execution of the task, feature extraction and the encoding of the new articles in the real time. So for that, we have performed some this particular technique on the text based data. So the data set comprises two sets of newer data like politics and the entertainment, labeled like gossip cop and the politifact data. For this research, only the textual content of the news articles was utilized yet. So we can say that the summary of this we have performed here, the analysis is like already we have performed this techniques, base classifier techniques like KNN, NB, decision tree, SVM, random forest. This particular base classifier with the text embedding systems, we can get the result for the accuracy, precision, recall, and F1 as shown in this particular table. And again, for the classifier, we have applied our model on the text, and the same text embedding technique we have used for the bag of words and TF IDF. We can improve the particular result by 5.34% on an average. So the conclusion for this particular Nobel framework is for the real-time false news detection on the social networks is introduced and presented in this particular research work. The majority of the prior strategies employed text-based techniques. However, this particular proposed model is using the multimodal transfer learning techniques to address the limitation of the previous approaches by incorporating a multimodal feature extraction block and the classification block. This particular architecture efficiently captures the context-based features using the pre-trained multimodal trained and on the large scale data set. So the here I'm concluding the proposed model embedding methods have proven to be outperformed by 5.34% while by considering the text data currently. So in future, the approach can be implemented on the real world data set and the multimodality by further exploring this particular area. So herewith I'm just conclude, and uh, if you have any question, ma'am. So
Questions to the presenter, please.
any questions you have, ma'am, please.
Any questions from the audience?
Okay.
So may I ask one, Sudha? Yeah,
Yes,
Gayatri
ma'am.
ma'am, please.
Yes.
No, I was
Yes,
just
ma'am.
going to say, I think it was a good presentation and it explained it
Thank you.
correctly. So there's
Thank
nothing
you.
I mean, I
Thank you
know
so
when
much,
I read
ma'am.
the paper, I will have many more questions. So
Yes.
Thank you.
yeah.
Thank you so
It's an
much, ma'am. Thank you
interesting
so much,
area to
ma'am.
work upon. I would
Yes,
like to
ma'am.
actually ask a question regarding time complexity, because you are talking that you would be actually identifying the news as a fake, real time. So time does
Yes, ma'am.
matters. Uh,
Yes, ma'am.
so
Act-
what inputs do you
actually,
have?
ma'am, I have proposed this particular model, but right now I have just worked with the text-based contact. I have not right now we have not taken any real-time data from the real data set. We have just taken the polity fact and gossip data and we have applied on that. So definitely we can focus on this particular time complexity when we can apply this particular model onto the real base.
Okay, thank you. So
Thank
may
you
we
so
Just
have
much,
one
another
ma'am.
more
presenter, please?
one more
Yeah.
comment. Maybe,
Yes, ma'am.
when you present this, if you give one example of what was actually done, that will give much more clarity for future
Okay.
presentations. Yeah. Yeah.
Okay, ma'am. Okay. Okay, ma'am. Thank you so much, ma'am.
Can we have another presenter? Paper ID 124,
You
classification
need
of
to stop
exaggerated.
sharing, Sudha.
Yes, ma'am.
Is Shriram another presenter?
No, ma'am.
Okay. Patel sir, can
Yes,
we?
just
Can yes.
Sriram, you are a presenter, so you can share your screen.
Sir, I'm not presenting today. My presentation is tomorrow.
So who is the next presenter?
Who is author of classification of exaggerated news headlines? Please raise your hand. You may unmute. So I don't. Okay, Mapitsi.
Let me make
Yes,
him. So you are the presenter, so you can share your screen.
thank you.
Yes, we can see your screen.
Okay, good morning.
Morning.
Today we'll be presenting our work titled Classification of Exaggerated News Headlines. In this presentation, I'm going to take you through introduction, problem statement, solution, results, and conclusion. Now, what is text classification? Text classification is a method that automatically assigns labels to a given text by utilizing machine learning and statistical method. It is also a subtask of natural language processing, which involves other tasks such as topic classification, authorship identification, and others. The aim of text classification is to categorize given text or documents by labels. Now, as human beings, we rely on the media for the consumption of news. Therefore, the media is one of the most sorry, the media. Can you hear me? Can you hear me?
Yeah,
Yes.
we can. Please continue.
Okay. The media is one of the most significant sources for providing information about what is happening in the world. But with the large number of users of social media, the media tend to oversell or mislead readers with exaggerated news. As a result, this poses the credibility of news and make it difficult for readers to identify non-exaggerated news. This is a presentation of our proposed architecture. In our proposed architecture, we inject data. So I will unpack more about our proposed data in the next slide. We inject data, then we pre-process our data by removing numbers, special characters, stop words. We also implemented the feature extraction known as TF-IDF, to transform the natural language into a feature presentation that the models can understand. We then split our data into 80% of training and 20% of testing. Then we normalized our data to remove anomalies. We then fed our 80% of data into our proposed machine learning models. Then we used our test data to test the trained model to predict the news title as exaggerated and non-exaggerated. In our work, we used newspaper data that we have acquired from our previous work, where we developed a natural language processing technique to identify news title as exaggerated and non-exaggerated. The data contain 49,772 titles, of which had exaggerated and non-exaggerated labels, and there was a high frequency in the non-exaggerated, which shows that our data is actually unbalanced. This is a representation of our data. We represented our data with the world word cloud. The letter and bold words such as South Africa, ESCOM, and world and others are the most common words that appeared in our data. And also this word cloud can also help us identify common topics in the news headlines. In this work, we have explored different kind of supervised machine learning algorithms. We have explored logistic regression, XGBoost, decision tree, and support vector machine. Logistic regression is a supervised model that is used to predict binary or multi-class. And the XGBoost is a gradient boosting pattern designed for lightweight and flexible distribution. The decision tree can also be either a supervised machine learning algorithm that can be used for regression and classification problems. Also, the support vector machine can also be used for the regression and classification problems. The support vector machine has a set of mathematical functions that are known as kernels. They are used to transform the data into the required form. So in this work, we have explored the use of these different kernels. So I will unpack more about the kernels and then over the next slides. In terms of the model evaluation, we used the following model performance metrics for model evaluation, known as accuracy, score, and confusion metrics. So if I may highlight, one of the reasons why we chose F1 score is actually because our data is unbalanced. As I have mentioned in the previous slides, that we actually trained 80% of our data and used 20% as our test data. So what we did first is that we fitted the support vector machine to the training data with the default parameters, and then we fitted the SVM models of different kernels, linear, RBF, sigmoid, and polynomial to the training data, and then so that we can training the model, and then from there we can observe that actually amongst the different kernels of the support vector machine, linear was one that performed better in terms of the F1 score measure. To further improve the performance of our models, because our data is unbalanced, we implemented data augmentation to overcome the imbalance by increasing data size, by actually introducing artificial noise to the minority label of our dataset, which was labeled as exaggerated. So from table A, these are the results of our models before we implemented the data augmentation, and table B is the results of our model after we have implemented the data augmentation, after we have oversampled our data. So we can actually observe that actually the implementation of the augmentation have improved the performance of our models. To further evaluate the performance of the oversampled models, we performed a confusion matrix where XGBoost was able to correctly predict 72% of news headlines, of which 47% were correctly predicted as exaggerated and 25% as non-exaggerated. Linear SVM was able to correctly predict 84% of news headlines, missing only 16%. From the results of the confusion matrix, linear SVM seems to outperform all of the proposed models. In conclusion, we proposed a method for classification of exaggerated news headlines. The proposed method uses machine learning algorithms such as decision tree, SVM, logistic regression to classify the news headlines as exaggerated and non-exaggerated. Our method was able to classify the exaggerated news and non-exaggerated news headlines. In our future work, we will use large data sets and also use the deep learning methods such as LSTM and others. Thank you.
Questions, please. Anybody?
A good presentation, well presented also. The slides were also quite clear.
Thank you. Thank you so much, ma'am.
Thank you, Mapatsi. Can we have next presenter, ma'am? Okay. Paper ID 144, inappropriate text detection and rephrasing using NLP. Please raise your hand. There's a button over on the top. Mapitsi, you may. Acha, we will have to convert her as a non-presenter.
Yes, just
Authors of, yes. Authors of paper 144, anybody is there? Please raise your hand to help us understand.
44, just a minute.
Nobody is raising hands. So,
I think they are not here. Like,
okay.
Maybe we move to the next paper. Yeah.
Yeah, paper ID
Yes.
340, a novel approach for suggestions on law-based problems.
he's not here. Like, so we need to move to the 285.
Okay. 285, predicting suicide ideation from social media text. Nobody is there and floor is ours.
144.
One, two, and three of them are not present.
144, author of 144 opted for this online live presentation. But
Okay.
right now, I think he's not here.
Someone's come in, Neelam Patil, I don't know.
Author of paper ID 285. Are you there? 285. Let me check.
I would have thought all the paper presenters would be excited to present and be there before time.
Very true. And option
285.
of online also always increases excitement. No, it's possible to
Yeah.
present from anywhere. It's a good opportunity provided by organizers.
Yeah. Otherwise, physically going sometimes becomes very
At
difficult.
times become difficult.
Yeah.
I think
While-
they are not here.
Okay. So, I mean, just a question because we have others. Dr. Patel, what happens to these three paper presenters if they don't present in the conference?
Can't tell you right now.
Okay, fine. So anyway, Dr.
We
Jain,
are
that gives us a chance. We need to connect outside icSoftComp. Thanks for Dr. Patel connecting us. But
Yes. Yeah. Nice to meet you, ma'am, here.
yeah,
this Venkatesh.
I
Venkatesan.
thought he was,
Oh.
yeah.
Venkatesan, you want to present your paper? Not here. So again, I am repeating, if author of paper ID 144 and 285, if you are there, then tell us so that we can make you the presenter. Not here.
Dr. Miguel, hello.
So I think we can have like this platform for networking.
Yeah,
We
that's what
have-
I was thinking. I
we-
can see Dr. Miguel active since beginning. So glad to have you here, sir. Glad to meet you. Hello.
Sir, you can make your microphone unmute. We also, Dr. Kanata is here. Yes, Venkatesan, you want to present your paper now?
Me?
Yes.
Massimiliano? As you like. If you want, I can go.
No, Dr. Kanata, not you.
Ah, okay.
I'm asking for the Venkatesan.
And he's put up his hand, so
Yes,
Yeah.
that's right.
you made him a presenter? Not speaking.
now. Let me make. Venkatesan, you are like a presenter now. So if you want to present. Is not speaking.
Gayatri ma'am. Earlier, I was with Gujarat Law Society for 12 years. I heard your name a lot, but I was not fortunate enough to meet you.
Okay.
Yeah.
You were with
So, and
Harshal,
actually, I
that
could
means.
see, yeah,
You were with
yeah,
Yes,
Harshal.
Harshal, Bhushan
Venkatesh.
sir,
Yeah,
RP
yeah,
Soni
yeah,
sir.
you share that, sir.
So that means you do come to Ahmedabad once in a while.
Once in
So
a
we
while.
should.
2012, I moved to Jaipur. I was with JK
Okay.
Lakshmipati University. I joined JK Group, JK Paper, JK
Okay.
Tire. They opened up in university in Jaipur. And then
Okay.
last year, I moved and joined Dr. Priti Sajja, Dr. V. Yeah, you might be knowing everyone.
Show me my slide.
Yes, we can see your screen.
Yes.
What's your paper ID, Venkatesh? 262.
It is not in
Clear
this
me, sir?
scheduled in this session. Huh?
Yeah, yeah, 130, sir, madam. 130.
130. So would you like to present now? Patel sir, shall we allow? What should
Yes,
how
we
should
can
we go
allow.
about? Okay.
Yes, we can.
Yeah, my slide is show me, sir.
Yes, it is visible. You can start your presentation.
Please click
Very,
slideshow to make it more visible. Or press
okay.
F5 key.
Otherwise, you can start. No problem. It's fine. Right, Dr. Jain?
Yeah, my
Yes,
paper
yes,
ID
please.
is
You
my
can.
paper ID is 262. Yeah, clear me, sir.
Yes.
My paper ID is 262. My topic is optimize path planning technique for navigational control of mobile robot using the crossfire algorithm in obstacle environment.
You may continue.
Yeah, yeah. My abstract is my research articles is better path planning from the goal position to target position to goal position, reaching to the mobile robot within using for the optimization technique, using for the algorithm in crossfire algorithm. I have created to the crossfire algorithm within 27% of obstacle and frame to the grid map is 6 column and 7 row within a grid structure. And that point is by reaching the point is 10 to 0. This 10 is a starting point, 0 is a goal point. For fourth step is for remaining grid structure is square box is distance was treated to the infinity. The distance was updated to the formula for n distance equal to current distance plus 1. Within UC for the VRAF simulations, my accuracy deviation is 4.6 percentage. My deviations accuracy deviation percentage. Introduction: the basic of using for the mobile robot, using for the military and space and medical devices, using that mobile robot within using for the path planning created to the structure. For third point is robot traveling for the particular point within path planning is reaching to the goal point. Next last topic is safely navigate around the various places and navigation through the goal point. This problem identifications. My problem identification for the BRAF simulation software using that and experimental analysis can be comparison to the this two values. The particular accuracy value reaching to the 4.6 percentage, and the total area of considered for the 350 into 300 centimeter. The simulation distance is covered to the 270.97 centimeter, and then 21.58 second. and experimental phases reaching to the 283.87 centimeter, and the time will be 22.59 second. Within consider for the 27 percentage of obstacle, and my crop structure is based on the crossfire algorithm, the start point and goal point. This destination point reaching to the start to goal point. Fourth image is considered for the starting point is 10 and goal point is 0. Within a different wave of path planning, moving of mobile robot, I have considered for the shortest distance moving from the mobile robot within 10 to 9 and 9 to 6 and 6 to 5 and 5 to 1 and reaching the goal point. This point is very shortest distance. Remaining different path planning is known. This distance will be high. Comparison to the this distance is a different pathway of robot movement for the goal pointing to the this image, and the using for the algorithm, basically using for the algorithm in crossfire optimization algorithm.
Venkatesan,
Using laser
your
for the
voice is
maximum distance and the maximum minimum distance you'll find out. Pseudocode is for the x not equal to equal to n. And the set order distance is the of this minimum distance value.
Venkatesan?
And the crossfire algorithm using the equation
Hello?
number 9 for
No, your
yeah,
voice is getting echoed.
yeah,
Your voice is not clear. It is
yeah, okay,
echoed
okay.
one.
Yeah, some tower problem.
Okay. But the last words which you spoke were clear. You should try speaking.
continue. Venkatesan, please
Yeah,
continue. Continue.
yeah, okay. Clear me, sir?
Right now,
Yeah,
it's
yeah,
You shall
crossfire
continue which
algorithm
you will
is
try to adjust.
okay, okay. Crossfire algorithm, basic of crossfire algorithm for initial parameters, maximum distance and minimum distance. Find out. Updated the equation number 9, and for the crossfire algorithm using the distance for 0, 3.5, and crossfire optimization for question equation number 8. The current crossfire back to the boundary lines, and iteration will be continued iteration plus 1. Either this can be find out the best solutions, and pseudocode crossfire algorithm using the within 5 steps. Step number 1, for each node is an n graph n into distance equal to infinity. Second step is create on empty list. Third step is goal point. Goal point means 0. It can be adding to the goal at a listed. Fourth step is list not empty. Let the current equal to first node in the list, remove the current from the list. Step number 5, for each node is the n that adjacent current n into distance equal to infinity, n into distance equal to current distance plus 1. Add n on the back of the list and end. This can be reaching to the goal positions. This a VRAP simulation result can be find out the VRAP. VRAP means virtual robot experimentations, path planning, simulation analysis for the mobile robot. Within consider for the 6 experiment to find out. It can be start to goal point can be reaching to the robot. Can be tabulation will be so that the tabulation will be the so that a simulation values and the experimental value. It can be difference between the simulation value and the experimental value. Finally, this 4.63%. and simulation value is 270.97 and experimental value 283.87. This graph also shows so that this can be reaching to the robot starting to the goal point within the shortest distance point find out and can be reaching to the goal point. This experimental result can be robo will be considered simplification of robo will be considered small robo. Start to goal point reaches starter distance will be find out the simulation time and experimental time will be find out. Average of 21.58 and experimental time was 22.59 with the difference between the value of 4.57. And my conclusion of the using for the crossfire optimization algorithm method. Second step is the method is using for the target and destination reaching to the version of cross optimization algorithm using to that goal point reaching. The second step using for the robo in simulation for Kuporo 3 was applied to the control and optimize navigation using the crossfire algorithm. In table number 1, table number 2 can be find out that both the simulation and the experimental values within less than 4.6 percentage. My exceeding value is 4.6 percentage. It is a proposed value. Already previous value is 5 percentage. This value 4% will be reduced. This maximum value is 4. This my value is 4.6 percentage. They were better than this value. This energy consumption and the shortest distance point will be consumption this value. The future work is for multiple mobile robot using that future work and hybrid potential field path planning algorithm and A star and RRT genetic algorithm and proposed algorithm using that. This is some reference. Thank you, sir. Any other question, ma'am? Answer.
Any question from the audience? If anyone has a question, then you may ask.
Venkatesan?
Yeah, ma'am.
Yeah, I have one question.
Yeah.
You actually explained very well grass fire algorithm and its
Yeah.
application in your area. Why did you compare it with other standard algorithms, existing optimization algorithms for the same problem?
Yeah, sine and cosine algorithm, ma'am. Sine and cosine algorithm within energy consumption is 5%. My algorithm using to the energy consumption is deviation 4.6%.
So what are the characteristics which you could identify of grass fire algorithm which made you get these results?
Create structure, ma'am. Create path planning. Create path planning using for the MATLAB. And create path planning structure is very shortest distance reaching to the goal point.
Okay, thank you.
Thank you, Venkatesan.
Thank you, sir. Thank you, sir. Very thank you, sir. Thank you, madam.
So Dr. Jain and Dr. Yes.
We can give a last call to others, 144 and 340 and 285. I don't think they are here.
They are not here.
Okay.
So you may conclude the session, Dr. Jain and Dr.
Gayatri ma'am.
Sorry, I was out for 2 minutes. The student was presenting a paper in the other track, so I was just there.
No problem.
So I didn't hear what you said. Yeah.
So ma'am, they are expecting us to conclude now.
Oh, okay. Maybe you can start, Sonal.
Okay, sure. So we had 3 papers presented in this session. I believe it's a good start for the conference because all the paper presenters were really good, and I could see that the presentations designed by them were very well curated. And I would like to thank Dr. K.K. Patel for inviting us in this particular session. Thank you so much, sir. And I'm glad to connect with experts available over here, specifically Dr. Gayatri. Thanks, ma'am, for being with us over here. Ma'am, please.
Yeah. So as Dr. Jain mentioned, we had 3 papers, and the presentation was good, at a good beginning to the conference, and let's hope for a good time ahead with lots of 3 keynotes, 6 expert sessions. So we're going to
And
have a good
19
time.
technical session and
Yeah,
13 technical sessions.
yeah,
I think
and lots of technical sessions. So it's going to be a good day ahead, and
Thank you.
not day, I should say days ahead. Next 2 days,
Okay.
right? So yeah,
Thank you, madam. Thank you.
yeah, right.
So I'm really thankful for sparing your valuable time to chair this session, both of you. Thank you very much. And like our keynote speaker are ready here. So I think we can move to that. So like it's a first keynotes. Dr. Aptis, are you there? I make you the presenter. I made you the presenter. You can share your screen. Dr. Theophanis Speed Aptis.
Hello, can you hear me?
Yes, we can hear you.
Yes, give me one moment, please.
No problem.
Okay. Hello.
Yes.
Sorry for this delay. I just entered my office.
No problem. You are just delay for 2 minutes. So no problem. It's fine.
Okay, let me share my screen.
Yes.
Can you see my screen now?
Yes, it's visible.
Okay. Okay. Hello, everyone. I'm Theophanis Raptis. I'm glad to attend this year's version of conference. The talk's title is on the input representations and uncertainty estimation for wireless positioning. Why is that? Because wireless positioning is a traditional problem with, let's say, several difficult instances. Input representations because when we use machine learning and deep learning method, it's not straightforward how to represent radio signals. And uncertainty estimation because when we use, for example, synthetic data sets, there are some issues there. And let me explain. So in this brief talk, I will give a very short introduction on why we select the positioning problem to showcase those concepts. I will explain some key issues of the problem. I will present why let's say the data-oriented techniques are very contemporary for this kind of problem. What representations we can take into account, some uncertainty-focused insights based on some performance evaluation, and a small discussion for related extensions. So as most of us know, the Internet of Things concerns a very large number of tiny smart sensors, which come with severe limitations, and a part of which is the wireless communication and networking. So such networks can be deployed in an area like with buildings, for example, outdoor area, or be embedded in various devices or even implanted in bodies. They can be, in various use cases, self-organized, and they can cooperate to each other, those devices. And there are many challenges regarding the various aspects of locality. Let's say such an ad hoc wireless network is crucial for sensing important events and ambient conditions, for propagating the data, and also for conducting mission critical operations. Now, traditionally, there are many problems connected to such deployments. There are topology problems, connectivity problems, synchronization problems, coordination, wireless positioning, which we will present today, routing, data management, energy optimization, mobility management, and security. So those problems have been traditionally addressed by many researchers during the last decade, let's say. But the emergence of learning methods and the potential access to big data sets have given us the opportunity to see those problems, and especially their difficult instances, through a different prism. Now, why the wireless positioning problem? The location information of nodes is fundamental in order to perform specific actions, to provide location stamps of the sensed data, to track or localize moving objects and entities, to monitor the spatial evolution of various phenomena, to achieve load balancing, form clusters, facilitate routing, and perform efficient spatial queuing. The key issues, the questions that positioning techniques can address, can be, let's say, tessellated down on the basis of the fundamental questions in this field. For example, what to localize, the reference, anchor, mobile cooperative nodes, etc. When to localize it, like one shot in real time, on the fly, periodically. How well to localize, what is the expected accuracy error that we can tolerate, where to localize it, and in what manner, in a centralized manner, distributed manner, and how to localize it with different methods that exist. Now, there are mainly two cases of, let's say, methods in the literature for conducting localization. The coarse-grained and the fine-grained methods. In the coarse-grained methods, we typically use very minimal information. So, as you can see in this slide, those methods usually use some geometric properties of each deployment, and they are using various let's say, geometric rules in order to more or less identify where the node of interest to be localized is. And there are also the fine-grained positioning methods, which use more detailed information, such as, let's say, properties of the wireless signals or properties of the node itself in combination with a wireless signal, such as the angles of arrival or departure. Now, since this problem is very traditional and has been addressed in the past decades, the question is why to revisit this problem now? The answer to this question is the following. This problem has a very difficult instance that remains, let's say, not efficiently solved or even unsolved in some cases. The case of accurately positioning, accurately localizing a node which is situated in a non-line of sight position with respect to the base stations that we can control. Especially in the case that we can control just one base station. So if we have a single base station that is receiving signals and a device, one single device that is in an unknown position and that we need to localize, this is very difficult problem because the geometrical approaches will typically not perform well because we don't have enough information, the coarse-grained approaches. The fine-grained approaches will also not perform well because of the let's say the additional noise that can be introduced by the non-line of sight setting, which can further complicate the analysis. However, like the last years with the emergence, let's say with the re-emergence of machine learning techniques, an idea has been to use machine learning on data sets that can come from such problems in order to address also the difficult instances. A visual example of the problem that I'm mentioning would be the following. Like on the right, you can see the base station device that we control, and on the left you can see the node that needs to be localized. And this is, let's say, they are located in an outdoors environment with some buildings around. So what you can see here is some radio paths. You can see the radio path K2 that is in line of sight radio path. And it has, let's say, a bolder, it's drawn with a bolder line because its radio characteristics are stronger. And we can see also the radio path K1 that is a non-line of sight radio path, which arrives at a base station with, let's say, lower power value. Also, you can see the angles of arrival and departure. Now, imagine if this, so in this case, there is a line of sight, let's say, communication. But imagine if the left node was slightly higher, the radio path K2 wouldn't exist, and the problem would have been very, very difficult to solve. Now, a trend in the literature of wireless communications, which has emerged during the last 12 months, let's say, in an accurate manner, is the production of synthetic wireless data sets. This, let's say, this was not, for various reasons, was not trending in the past, because partially because also it was not so straightforward to produce such data sets. But now there is this capability. By synthetic data sets, what do we mean? For example, in this slide, you can see the so-called WireD dataset, which is co-produced by Huawei, and contains is a simulated, let's say, a set of simulated data, big set of simulated data. So this dataset is around 10 gigabytes. Which is considered very big because each entry is just a couple of numbers referring to the radio signal. So 10 gigabytes for a couple of numbers is a very big source of information. It contains, as you see, some urban environments with scattered buildings based on real cities across the world. and provides locations of multiple base stations and multiple, let's say, devices, source nodes to be localized among others. I mean, this is the problem that we focus today. Also, other problems can be addressed using such datasets. And also provides the radio link parameters. Now, the specific dataset comes with two scenarios, the so-called dense and the so-called sparse. In the dense scenario, we have 10,000 environments, 5 base stations, and 30 devices. While in the sparse scenario, we have 100 environments, 100 base stations, and 10,000 devices, which is also very convenient because, I mean, from the machine learning perspective, we can achieve there, we have some difference in the training and testing phases, we can achieve domain shifts, etc. Now, the formal definition of the problem in, let's say, based on the information that this dataset gives us, could be the following. Find an estimator that minimizes this difference, which is the, let's say, the function of the radio and the map characteristics, which is, let's say, indicatively the position of the base station, the map itself, the path delays, and the angles of arrival and departure, minus the ground truth. So we need to minimize the error, the accuracy error on the predicted distance on the map. Now, a very important, let's say, part here in this analysis is how, given that we want to design a machine learning model or a deep learning model, how we will represent all this information. And this is not a straightforward task because when we are talking about radio links and their inherent characteristics, let's say there is no standardized format of representing them. So what I will show in those 3 next slides are 3 alternative, let's say, ways of representing the input, 3 different input representations. The first, most straightforward one would be the vector input. In this case, we would take as an input a 5-dimensional vector, which would include the very basic parameters of the problem, which would be the, let's say, information about the map, the location of the base station on the map, the path, radio path delays, and the angles of arrival and departure as some, let's say, a set of numbers. The network that can be built on this information was already is already existing in the code base of this dataset, and 1024 and 256 layers of such size, plus an additional output layer which produces the coordination, produces the X and Y coordinates of the device to be localized. And the loss function is the RMSE. Now, another idea would be to, instead of vectors, to have matrix input representations so that we can leverage the rest of the. So in the first method, I forgot to mention that here, let's say that this method takes only the shortest path of the radio link, being a vector input. Now, in a matrix type of format, we could leverage the other radio path. So each pair of device and base station comes with multiple radio paths, let's say. And we can leverage them, but for understanding if we can use more information, we can use functionally more information, and instead design a simple convolutional neural network to broaden the usage of the additional information. Okay, in the figure you can see the architecture of such a network. Of course, the design choices can be different, but in this case, I'm just showing let's say the different types of input representations that can be obtained. A last and more interesting input representation could be the image input representation. So a network could take, a neural network could take as input the image of the map with different channels, let's say, where the first channel can represent the map encoded as a binary matrix. The second channel can encode the radio paths, which are arriving at the base station. And the third channel can encode the radio path information, but on the point of departure from the device and the available information that we have on this. Encoded as, depicted as rays. So this is a design choice, starting from the base station location and going to the direction of the equivalent angle of arrival or angle of departure. Why from the base station location? Because we are unaware of any other location on the map. We cannot use the device location because this is what we want to predict. And here you can see a visual example of this input representation. So you can see on the left, you can see the ground truth of the data. You can see the map, you can see the base station and the one device, and the corresponding angles. Then you can see the channels of this network architecture, which are first channel is the map, second channel is the first set of angles, and the third channel is the second set of angles, but both grounded on the base station location. And then it's the predicted output. Now, the purpose of the figures now that I will show next is, of course, to perform, let's say, an initial evaluation of those concepts. Let's say the performance efficiency is not so high, which was expected because of the limited information that we have given to the models. But this evaluation serves as, let's say, as a facilitator to understand some issues regarding the uncertainty of the results. So in this case, we use the RMSE for the predicted locations in meters as metric, and of course also the accuracy at given x distance of meters, which is defined as the ratio of samples for which the predicted location was within the x meters of the ground truth. And in the analysis, I will show that we have reported those subjects in both cases, but also cumulatively line of sight and both non-line of sight. Now, on the actual wireless network side, implementation here meaning the implementation of the neural networks, but on the actual synthetic, let's say, wireless network side, in this table you can see the characteristics that were being taken into consideration, specifically not the second column, but the third column, let's say. Which are typical of a standard wireless setting, let's say, in modern cities, etc. So in this case, we trained and compared the performance of the three models that I presented, so as to see how different input representations and architectures can behave. And we focus on both the line of sight and the non-line of sight cases. Now, this is, let's say, a very core figure, which is the accuracy result. As you can see, of course, when we take into account all the sets of all paths, both line of sight and non-line of sight, we can achieve a higher accuracy with respect to positioning wirelessly the node. However, having excluding the line of sight paths and taking into consideration only the non-line of sight cases, we can see that the accuracy significantly drops and also affects the overall one, by the way, if we take them together collaboratively. Here, what we can see is that even the MLP can work quite well. The MLP is the vector representation, can work quite well for the line of sight with 99% accuracy, but significantly deteriorates when we take into account only the non-line of sight case, which is expected as it uses only information from the shortest path of the radio link. A surprise here is that the CNN with all the paths included performs worse, and this might be an issue of the architecture. Of course, it's not currently explainable, but some speculation can be that it can be caused due to overfitting results. Here you can see some indicative input samples and predictions now for the image input representations. So in this case, as you can see, we have, except for the predicted location, let's say on the black figures, which is the predicted locations, except which are the blue crosses, let's say the blue X. Except for this, we have also drawn some red areas which signify something else. The red areas signify let's say, the similarity of their points underneath to the predicted location. So the similarity of the radio links that a node would have if it was located there instead of being located in the ground truth blue X. And as we can see here, in some cases, not in all of the cases, like for example, you see in the first image, this is not the case. So the red area is exactly on the blue cross. But for example, in the third and in the fourth case, we can see that there exist some areas on the map for which the image representation model believes that there actually is there is a similarity based on a similarity metric, let's say, of the radio paths. Of course, for the purposes of the problem itself, predicting something in this location would be a wrong answer. So we do not localize appropriately the device. However, this is a very good indicator of estimating uncertainties in let's say, the result production process. So the idea would be here to understand what if we were taking into account not just the top prediction that was delivered by our model, but also investigate the top 5 predictions, because maybe the model brings back some wrong predictions on top, which is, let's say, is the result of having the synthetic data with higher similarities across the map, and brings the truly accurate position like a bit in a lower place in the list of solutions. Here you can see indicative photos of line of sight and non-line of sight of applying this method, and we can see that indeed it can be more accurate, and the numbers verify this. So, for example, here you can see the error scatter plots where we compare, let's say, the error of the closest prediction among the top 5 candidates. instead of top one candidate with the top one prediction. So we have top one and top five predictions. Here again, we do an analysis between loss and line of sight and non-line of sight. As you can see here, again, line of sight behaves very well. Almost all the times, everything is concentrated around the diagonal, while the non-line of sight is a trickier case. Okay, I will close the talk now because I'm out of time. Again, here, this is another representation of the same effect. Concluding remarks is that single source, single based wireless non-line of sight positioning is an extremely difficult problem to solve. We can address this problem through, if we have available data through several different input representations from ML models or deep learning models in order to produce different outputs, and specifically if we use image representations, we can we can have a richer output. And the structure of the output then can be further used to estimate various uncertainty properties in order to produce more candidates of the source locations and detect incorrect predictions given by the model. For example, a conclusion that we can see through the numbers is that angle of arrival information is more important than the angle of departure in all of the models. Now, here you can see, by the way, one of our works, another work that is also interesting in this domain. The obvious extension is, can we achieve more efficient input representations to further boost the performance metrics? Then another very interesting question is, can we move those concepts from synthetic data to real data? Real data is very difficult to gather in this respect because signal data is very sensitive, is cyber physical. We need to gather them in the open, which means it takes too much time, too much effort. They are very fragile, etc. And assuming that we can we apply out of distribution methods in this domain shift? Can we generalize? For example, can I train a machine learning model on synthetic data, but then test it on the real data efficiently? So this is a core question. Conclusions. Machine learning helps to revisit traditional IoT problems that have difficult instances. Help approach the problems through a different prism, and help exploit the richness of the data that wouldn't be possible otherwise by using an and any questions are welcome.
Any question from the audience? If you have, then you can ask. Anyone? If you have any question, then you may ask the question. Okay, Dr. Aptis, I think no question from the audience.
Okay, thank you very much.
Thank you very much for sparing your valuable time for the icSoftComp 2023 and giving these keynotes to the conference. Very informative and thought-provoking. This keynotes is there. Thank you very much, Dr. Aptis.
My pleasure. Thank you.
So next keynote is by Dr. Massimiliano Canata. I welcome Dr. Canata to this icSoftComp 2023. He's working with the University of Applied Science and Arts of Southern Switzerland, SUPSI, and title of his talk is Reactive Monitoring System. His main research interests are like cartography, then remote sensing, and geomatics and geoinformatics. I welcome you, Dr. Kanata, and hand over this session to you. Let me make you the presenter.
Thank you for the invitation. It's a pleasure to be here. Okay, now I start sharing.
You can share your screen. Yes.
Yes.
On the top right side, there is a share
Yeah.
button.
Okay, so we can.
Yes, we can see your screen.
Okay, perfect. Thank you. So this presentation is about moving from traditional task-based and
Dr.
based on.
Kanata, sorry for
Yes.
interrupting. Your
Yes.
screen is not visible. It's visible only partially.
Like
Full
this
screen is
is
not
working.
visible.
Okay, so I will go with this without full screen. Okay. Is it working?
No. Only
Not
half.
yet. We can only see part of it. No, still more.
Okay.
I don't know why,
Full
but
screen.
I will try
Full
to change
screen.
the presentation. Yeah, I will try to share the entire screen. Okay. Then I move here and here. Like
yes,
this?
yes. Now it's
Okay.
visible.
Okay, thank you. So I was saying that it is about how changing perspective in managing data from environmental monitoring system, and particularly from sensor, because this data have been always managed based on time-based approach, so with scheduled task and things like that. So about me, I am very keen to the open source world and the open source stuff. So I'm coordinating my university. So I'm open research data stewardship, and I work within the Institute of Earth Sciences. And that's why you will see applications that are based on these kind of topics. At my institute, we collaborate with the local authorities, and we do manage under a mandate from the governments a number of different monitoring networks, and they are related to hydrology and meteorological observations. We also monitor groundwater levels and temperatures. We do evaluate also lake water ecosystem health, and we do monitor also permafrost, which is the ice within the terrains that now, due to climate change, is going to melt, and also we do monitor landslide displacement. So as you see, we have a lot of works in maintaining monitoring network with sensor deployed on the fields, collecting data, managing data, and then raising alert, alarm, or managing or feeding decision support systems. In these periods, there is a huge rush toward protecting from climate change's impacts that are threatening all the socio-economical and also ecological systems. So in general, there is a real push toward implementing effective systems that can help in reducing these damages to the natural system, but also to the socio-economic systems. And the wide picture and the trends is that to solve societal challenges and also ecological challenges, there is really a need of strengthening data production. So the idea is really to have more data, as much as data as possible, because this is also a problem depending of the location of the people around the globe, but the problem is global. So we need to try to make every countries able to produce such kind of data. And of course, like in the concept of Industry 4.0, also in the environmental world, there is this trend of moving from natural to virtual, so developing digital twins, so that observation fits models in the digital world that through data that continuously update and monitor the status of the situation in the real world, and then using algorithms and analysis try to extract knowledge that are then fed back to the decision makers so that they can take actions and impacts, and then these impacts can be also observed, and we can also detect how these impacts were benefiting the real world. So this is a general trend to try to use more data to provide wise information to the users. Another emerging concept is the concept of the data space. So to create virtual rooms where people can access and exchange data using standardized information and processes, and this virtual space should be also able to manage also legal and technical barriers, so that different type of data, which are not only sectorial but can be across different domains and disciplines, can be used to better understand the situations. A third concept that is on the wave is about creating these wisdom pyramids that goes from a large number of data and reach down the wisdom, which are the result of analysis that transform from raw data to understand information, and through then elaboration of knowledge, mixing different type of informations, and then at the end extract wisdom. So detail suggestion for the management of the reality. Of course, this can be achieved only through a multidisciplinary and collaboration approach, because different are the perspectives that monitoring system can look at, and different are the components that are in the game. So this is an example of what we do at our institute. For example, we do manage for the local civil protection applications that make detections of lake floodings. From the picture, you can clearly see that this is a delta of a river which is very flat, and every 6-7 years, with a return period of 6-7 years, we are expecting floods. Floods that produce a huge number of damages, are very expensive for the society. So together, the local administration, Canton Ticino, and the Meteo Swiss organization and civil protection, together with the academia, start this project to set up an informative platform that help the civil protection to manage this disaster. So we have data that comes from the monitoring stations that goes in the sensor data warehouse. They undergoes data validation, and then they can be shared with third parties, also players. But then this data goes together with the meteorological forecast into hydrological model that can perform forecast of the lake's level for the next 48 hours. And this result of analysis get joined and combined with other contextual data like GIS data, and produce an early warning decision system support system that the civil protection is actually using to manage such kind of hazards. Other example are the alarm of harmful algal blooms. So times to times we are expecting more and more cyanobacteria blooms in the algal, which is a toxic bacteria. So we need to have such kind of system that do monitoring and then can rise up alerts and maybe also forecasting, so to protect population and environments. Another example is this ALBIS project was a project that was dedicated to estimate the microclimate in the catchment hole, so that this is the most favorite location for the tiger mosquito to deposit eggs. And since in Switzerland the temperature is quite low. It can reach easily 0 degrees. Up to now, it was supposed that the tiger mosquito is not surviving. But in this particular context, the temperature is different. So we had this project that was able to monitor and create a relationship with the outside temperature and create some machine learning models to predict the disposal of these eggs. And other projects are monitoring of the lake water quality using different type of probes and combine all this information in a dashboard that can be used by researchers to as a data source to perform their research. And at the base of all the applications that I've shown, there is a software that we have developed in the last, I think, 15 years, which is named icSoft. It is an open source software and it implements the sensor observation service open standard, which is an international recognized standards to collect and dispatch information from sensors. And in these years, we have implemented and used this software in productions and in several research projects. And we implemented this together with the scientists from the different disciplines, so hydrogeologists, ecologists, and etc. So it is very, very helpful for us, and it implements a number of special features that are very useful for the management of environmental data. But now, as you can imagine, technology quickly evolves, and after 10 years, there are new ingredients that we can use to create a new recipe based on the knowledge that we have created in the last 10 years. So we try to redevelop such a kind of system, including cloud computing, open science, and IoT principles. So real time is very essential, and also the scalability and the availability of the system should be improved. That's a result of technology changes, but also the result of the growing number of sensors that we are deploying and we need to manage, and etc. So we started to develop this new system, and this also comes after some discussion with Meteo Suisse, which is the meteorological agency of Switzerland, that they also were thinking to move from a cron-based system to a reactive system. So this is a very current issues that several agencies are trying to change their own system and moving toward this new approach and technology. So we started to think about which kind of requirements we are looking at. So the first requirement that we want to support is the open source. So that solution should be open for everyone, so that wherever is the user in the world, he can take this solution for free and forever for its own purpose. Then we want this solution to be interoperable. This because we want to facilitate the integration of data, and one of the main issues that you have in the IoT system is really interoperability, because each sensor sellers propose its own format and system. So we need to really make interoperable such kind of data. Then we want, of course, to be it reliable, so applied and tested in production environments. And then we want such a kind of solution to be microservice based. So we want to have specialized services that are designed to perform some specific tasks within all the data workflow. Then we want to move from, as I said, task-based to reactive-based application. So every time something new from the real world is available in the digital world, we want that the different services are able to be activated. And how we want that they are choreographed. So, I mean, each services should know what to do, but works in harmony with the others, like when you see a dance show where each dancer knows his own tasks to do. And the advantages of such a kind of solution, of course, is the high scalability of the microservices, the reactivity of the components, and the atomicity of the processes, and the possibility to apply some DevOps and agile development approach. So for this reason, we decided to use as a central core elements of our application the OM observation. OM observation is a standard format that is international and open, and this is the standard that is mostly used by international authorities. So, for example, World Meteorological Offices or GCOS or the World Bank or Hydrological International Association. They use such a kind of core elements that provide the observations, not only with their value, but with all the metadata that are useful to make sense of the observation. So not only the values, but also the procedure that has been used to provide such a kind of value, which, for example, is very important to understand the accuracy of the values, also the quality, and if it undergoes some quality process, the time when it is released, and different type of times when the measurements was taken, when the result was available, and then for when this observation is supposed to be consumed. And of course, also the feature of interest, which is exactly the location and the medium that we are observing. The new approach use the event bus. So, like the basic idea is that the sensor produce some information. So, in this dummy example, there is a fire. So, a fire detector sends information about the detection of this fire, and then there are some subscribers to this event bus that different microservices. Some of them, two in particular, are interested in this information, and one will start the water system to end the fire, and the other will raise some alerts, and while the other microservices are not responding. And to deploy such a kind of event bus approach, we use Apache Kafka, which compared to MQTT, for example, protocols, is very highly scalable, it's durable, it's very reliable, and have a huge performance. So we can have high throughput, data are replicated in different instances, and also the durability, the message persists on the disk, and you can easily scale. And then on top of this event bus, we started to deploy and develop all the microservices that will consume this event bus. So first of all, how to feed this Apache Kafka bus? We can get data from the sensor from different communication protocols, and then use such a kind of data to feed the excuse me?
Sorry for interviewing.
Ah,
You may
okay.
continue.
Okay, thank you. No, I was saying that data from the real worlds can use different protocol for communication. And then so we created a connector that is exposed to the different communication protocols and inject this data into the Apache Kafka. And creating such a kind of connectors or producers is very easy. There is a very dummy example on how to create such a kind of connectors. And the messages that are produced into the Kafka, they can be specialized by different topics. They have a key and then they have a value, which generally is a JSON format, and particularly for us, this JSON format will be the observation that the standard OM observation that I've shown before. And the first issues that we have to deal is how to handle possible errors when you want to take this data from the event bus and inject into a persistent database for historical analysis, for example. So in our resource application, because once the consumer is awake and consume the data from the event bus, the message has been consumed. So if there is an error inserting this data into other applications, we have to manage it. And the solution that we implemented is to create another data streams topic, which is insert errors, where all the errors data that was not able to be inserted in real time to the application goes into this data stream. And then there is another processes that at different times consume data from this event bus and update the database for missing data. So after that, we want to be able to process in real time this observation from the data stream. So we implemented libraries that can be easily configured to calculate for different properties, like for example, rain, and different sensor or stations, different statistics at different periods and aggregation statistics. So based on this real-time calculation and update of different statistics, we can set up different type of alerts that can be evaluated using, in this case, in the example in the screen, there is a threshold functions that evaluate if some statistics overpass a given threshold to raise the alerts and identify a different severity. But this function can be also other implemented processes more complicated. In this way, we can in real time update data. As soon as we get a new value, we can get a new statistics and a new evaluation of the alert functions. And from one side, update the values of the statistics to be delivered to the data management unit or different users, but from the other side to raise alerts that can be used then to communicate risk. This is a short example, screen video of a producer interface that produce new messages, and you can see that as soon as the data has been produced, directly statistics are updated in real times, and so we can see how this sort of application can work. So we have seen how we can process data in real time and produce real-time alerts. And then these alerts, of course, are raised every time there is a new value, for example, that exceed the thresholds. So we will have a lot of alerts that should be handled with a different microservices that consume these alerts data stream and manage how to notify people, and so that people in the fields can be alerted in case of prediction of risk and in case of a dangerous situation to take actions. Also in producing notification to the user, there are a lot of things to be taken into account, because there is the risk of burden the user with a lot of alerts that then, if they are not verified, they can produce a different output from what we want. So that, for example, if we send too many alarms, people get worried and then are not looking anymore at these alerts, or for example, we have to consider different type of false positive alerts can drive to silencing the alert from the user. So we have created a different microservices that manage all these kind of things. So this is a short of application of the logic. So when an alert is raised, it waits for other certain period if other alerts are also raised, so that you can communicate both with a single message, but then every notify variation times, the system will check if there is new notification, and it perform a new message only when there are new alerts or the level of the running alerts are changed. And then we have also to identify a way to switch off the alerts. So we have to set some deactivation periods, and all these kind of things are run in real time every time that we get a new notification, new alerts. So far we have I've shown what we are doing to move from the ordinary time-based approach to this new reactive-based approach. But what are the perspectives? The first thing is that creating microservices architectures is very nice, but things can get quite complex quite soon. So you must be aware of being able to manage all the workflow and all the different microservices, which is a problem. Then we have to develop further this new icSoftMu approach with data array and multi-data stream extension, and take into serious consideration the cyber security, because there is a new law in Europe that is going to be approved the next year, that put the burden or assuring cybersecurity to the producer of the software and not to the user. And yeah, of course, we want to continue to deploy such a kind of application. And thank you for listening, and I'm available in case of any questions.
Any question from the audience? If you have, then you may ask.
Could I have
Yes.
a question? Hello. Buongiorno,
Hello.
Professor. Just I have a question. Okay, it's not on the application side, it's mainly on the tools that you are using. So I understand that the core is the Apache Kafka system.
Yeah, for the
yes, it's a very popular system, and A question there is for you as a user of the system, let's say, were you satisfied with the system, or there were some problems to, let's say, to point out that could be improved, etc., or you were satisfied with this system?
So far, with our experience, we are quite satisfied. We didn't saw many issues, but I have also to say that we are not managing a million of messages per second. So I don't know, because this kind of application, you have hundreds of sensors around in the fields and you collect this data, but I'm sure that we are not pushing the technology to its front or stressing too much the technology. But so far, everything is working quite smoothly.
Okay, thank you.
You're welcome.
Anyone else? You are behind the time, so thank you, Dr. Kanata. Thank you for sparing your valuable time. And we move to the next technical session. We are behind the time, so so next technical session is S2, and I would like to welcome the session chair for this session, technical session, Dr. Jatinder Kumar Saini. Sir.
Yeah, very good afternoon, sir.
Good afternoon. Okay, so he is working with Symbiosis University, International University, Pune, and I welcome him and I hand over this session to you, Dr. Saini. We have 5 papers in this session.
Yeah, thanks. Thanks, sir. So I will take the proceedings forward. So
yes.
We begin with our presentation with paper ID 28, multi-tenant servitization platform as a service model. I request all the participants to kindly stick to the timelines. Ideally, try to wind up your presentation within 10 minutes so that we can spare a minute or two for the questions from the audience as well as from the chair, panel, and my side. So, paper ID 28.
Author of paper ID 28, are you there?
Yes, I'm here.
Could you please raise your hand so that I can make you the presenter? Yes, thank you. Just a minute. Yes, now you are the presenter, so you can share your screen.
Thank you very much for this wonderful time to present. Okay, I just want to put this into
presentation
mode. Okay. Just a minute.
No problem.
Can you see it?
Yes, it is visible.
Thank you thank you very much. My name is Moses Radebe. I'm here to present my research paper, which I co-authored with the following individuals: Adeza and Buthe. I'm a senior software developer at the CSIR in South Africa. Okay, my paper is labeled Multi-Tenant Civilization Platform as a Service Model. So these are the contents: introduction, existing models, challenges to adopt civilization, observations, proposed model, findings and discussion, and also the conclusions. So currently we have a model called civilization, which most of the organization use in order to transform their products into services. Like for instance, we're having the Rolls-Royce, which designs the aeroplanes engines. So with this, they are able to civilize their engines in such a way that people are not buying the engine, but they are they can be able to learn it or to be able to acquire it. And then after that, while the aeroplane is the engine is in service, they can be able to monitor it online just to check whether is there any defaults or there's any problems. And then if there's problem, they can be able to detect them and be able to solve those issues, or be able to indicate that this particular engine needs to be serviced. So in such a way, we have different types of layers that they are able to implement. Like for instance, we have layer number 1, which is the physical thing, like an engine, and then which they implement a sensor, which is able to determine certain things. And then again, it requires connectivity so that they can be able to remotely collect the data and also remotely control. And then again, with layer number 4, is analytics, which enables them to be able to make some decisions and be able to get a useful information from that. And then from that point, they can be able to, with this information, they can be able to create value, create value within their organization in order to improve their products that they're able to create. So in a nutshell, this civilization model, it can be known as product as a service model, which brings a number of fundamental changes into business model, which brings one, value creation through data analytics and information, value creation through monitoring and remote control, also encompasses maintenance and asset replacement. Like we said, if we want to change the engine, we need to know where the airplane is, and then we can be able to dispatch people who might be able to change the engine, or who might be able to do some maintenance in that particular engine. Such service delivery models also referred as vertical systems or as siloed-based systems, which are created for a specific domain and to solve specific problems. So the issue is that when we have this kind of systems, if we need to do some maintenance, the software developers has to go through number of steps or through software or reverse engineering in such a way that because of these particular services, they are tightly created or tightly coupled, because of they include the sensor, they include the network, they include the software. So it is very, very difficult for individual to be able to reverse engineer, and then of which it takes a lot of time, and then it also incurs a lot of high cost. So there are other individuals like Lee et al. Who has proposed a new model whereby they have what called a horizontal architecture, whereby it enables them to host multiple vertical systems in such a way that to relieve the manufacturers from concentrating in to create what we call a parallel system, which is that product as a service. So to concentrate only in the production of their own products. And by so doing, it is able to increase their continuity in such a way that they are now focusing only in the development of their products instead of focusing on a parallel system which creates a value. So with this, they can be able to design their systems, and then in collaboration with individuals who owns this horizontal what call architectures, which will allow them to host them. And by so doing, it also eliminate the cost of hosting, the cost of maintenance, because of the maintenance of the system is going to be done by the horizontal architecture owners. So hence in this
Mr.
paper,
Moses,
yes.
Mr. Moses, I am sorry, I am interrupting you in between, but I think you need to speed up a bit because you are still
Okay.
talking about the background, and we have just 3 minutes left.
Oh, thank you very much. Sorry for that. Yeah. So we have other users who have created their systems like this one here, which is able to host multiple vertical systems. Okay. So I'm just going to run. And then we have another one who has created this system whereby they're using the mobile app, the mobile phone here, which use the Bluetooth in order to be able to detect or discover any available sensors, and then of which is having the IoT side and also having the cloud side. Okay, so this one is going to be collecting information and it's going to be pushed to the cloud. Okay, then we have another one, Kim et al. Also, they have created their own horizontal models whereby they've created this broker system, which is based on the Android device, which is similar to a Raspberry Pi, and then meaning each and every tenant, if he wants to host his application, he needs to buy this. And then with this, he can be able to detect or discover any devices that's going to be attached. Okay, but the issues that we have with the civilization is that people don't want to adopt it because of the fear for data sharing risk, and then also data sovereignty. And then again, David indicates that individuals, for continuity, they need to develop hybrid strategies in such a way that they are able to continue with their traditional processes while they have what called allow other organizations to host their systems. And another thing is the long-term viability, because of organization need also to determine whether they can be able to outsource certain processes. And then because of what? Because if they don't do that, if they outsource everything, they might lose their traditional processes, and then that can be able to what can stop their business continuity. Because of technology, it can benefit you for a certain period, and then it can change repeatedly. Okay, so what we have observed is that with most of the multi-tenant designs, they are sharing a schema, and then this can have issues in terms of what called the sharing of data, because of individuals can be able to, if we are using a shared schema, each and every tenant is going to have the tenant ID. So if the administrator can make a mistake to say select all, he can be able to get other people's information. And by so doing, it can have an issue in terms of trust.
Mr. Moses, I am sorry. Mr. Moses, I am sorry. May I request you to wind up within 1 minute, please?
Okay. Let me just continue. So in this paper, we have proposed this model whereby
maybe you can proceed to the conclusion directly.
Okay. Okay, in this paper, we have proposed this platform with an aim to allow tenants to be shareholders into our applications, because of most of the previous systems that were developed, they take tenants as not participant, but only as the users of the system. So in our system, in order to improve software development, and in order to allow software developers to be able to understand the requirements, we allow the tenants to be the players in terms of giving us their requirements, and then so that there should be interaction between the software developer and the tenants, and then by so doing, it's going to improve ownership, whereby the tenants they're playing a crucial role. Okay, so what we intend to do in future, the last thing, is to look at the open source multi-tenant frameworks to avoid in reinventing the wheel, so that we can see how we can be able to contribute, what will be our contribution into this open source multi-tenant frameworks. Okay, thank you.
Okay, thank you, Mr. Moses. So if there are any questions from the audience, I will request for this paper as well as for the subsequent papers to kindly raise your hands. Otherwise, from my side, I have a few questions. Number one, why do you think that this is an application of fog computing vis-a-vis edge computing?
Yes, because of here we are including fog computing, whereby the fog computing is going to be based on a tenant's environment in order to improve trust, and then also to improve data security in such a way that their personal data should not be stored into a remote cloud. And by so doing, it's going to improve the trust between us and the tenants.
Okay, so did you go for the real world implementation of the proposed model?
Yeah, currently we are busy experimenting with the open source available sources, softwares.
Okay, so are you planning to implement it through Raspberry Pi or through Arduino?
Okay, currently we are considering Raspberry Pi Pico
Okay.
for small sensors. Yes.
Okay. Thank you very much for your presentation. We
Thank
move
you.
on. Yeah, we move on.
After finished my talk.
We move on to the presentation for the next paper, paper ID 134. Resource management through workload prediction using deep learning in fog cloud architecture. Paper ID 134, can you please raise your hand? Yeah,
Yes.
Pratibha, please go ahead.
Just a minute. Let me make her presenter. Yes. Pratibha, now you are presenter, so you may start your presentation and share with this.
So while Pratibha is preparing for the presentation, who will be presenting the next paper, paper ID 160, Energy Efficient Task Scheduling in Fog Environment Using TOPSIS. Paper ID 160, who will be presenting?
Yes, sir.
Please raise your hand.
Yeah. Can you please raise your hand so that we can identify you? Okay, yes. Sukhvinder. Okay. So Sukhvinder, you will go next after Pratibha is done. Yeah, thank you.
Okay, sir.
Are you ready, Pratibha? Author of paper ID 162, are you there? Pratibha, we cannot hear you.
Yes, sir. My paper ID is 162.
Are you ready for a presentation?
Yes, sir. I'm ready.
Okay, just a minute. You can start now.
Okay. My screen is visible.
Yes.
Okay. Good afternoon, everyone. My name is Deepak Kumar Singh Yadav from NIT Kurukshetra, and my paper topic is dynamic underload host detection for performance enhancement in cloud environment. These are the some outlines. And introduction, what is cloud computing? Cloud computing has transformed the operational landscape of businesses by offering the convenient and immediate access to a diverse array of computational resources, for example, server storage and application, many others services provided by the cloud computing. Cloud computing service provider often have functions distributed over multiple location, each of which is a data center. Cloud computing relies on sharing of resources to achieve uh, coherence and typically use a pay as you go model. Cloud
Deepak, I
computing.
think, yeah, Deepak, I think what cloud computing is and how it can be used is already well known to the scientific community present here. So maybe you
Yes.
can directly proceed to the specific methodology that you have followed and the results that you have obtained and the specific contributions that you have made.
Okay. Can I explain the some major issue? Then I proceed to.
Okay.
Uh,
Okay.
yes. In cloud computing, have some major issue. Host overload, host underload, storage issue, data migration challenges, cost management, and data security concerns. In this paper, I am presenting the host underload detection using the linear regression algorithm. This is a machine learning algorithm. And through this algorithm, we try to achieve a performance uh, and decrease the energy consumption and decrease the SLA violation. So these are the some work done in this area. And my main motivation is a underutilized host represent the insufficiency leading to wasted resources and increased operational cost. Aims to reduce the energy consumption, make spam is a whole time of process, and as well as cost without the degradation of the performance of the task. And linear regression is a very important algorithm in this area, so because in this area values continuously change. So 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 in this case linear regression is a best algorithm to handle this problem. My objective is we considering the three parameters. First parameter is a SLA violation, service level agreement, and second one is a energy, and last one is a number of VM migration. These are the some formulas used in this paper. Performance metrics all over represent the my whole uh, whole implementation performance, and also show the my proposed algorithm is a best algorithm in in this case. So in this formula, take a three parameters: energy, SLA, and number of VM migrations. And for SLA evaluation, this formula used, and energy consumption for this energy consumption calculation, this formula used, and VM migration this. So my methodology is a in this algorithm. Firstly, we try to detect the underutilized host, then through a linear regression algorithm, then we try to reduce the energy and SLA violation, and number of VM migration. When these parameters, three parameters used in this paper, very important parameters, because if number of VM migration is decreased, then also could reduce the cost and increase the performance. These are the my results. So in this result show the I'm compare with the our proposed algorithm, these some techniques: IQR-MNC, IQR-MMT, IQR-MU, LRMT, LRMU, MED-MC, MED-MMT, and MED-MU. And you see the my proposed algorithm decrease the SLA violation, energy consumption, and VM migration. conclusion is we present linear algorithm for host underload detection. This algorithm based on the machine learning objective of the present approach to minimize the consumption of energy, SLA violation, and number of VM migration, and compare with these algorithm. And in this, when we proposed algorithm, then use a cloud sim tool and with random data. So my future work is in this approach to use a real time data to detect the underload host and decreasing the energy consumption. These are the some references, and thank you. Any question?
Okay, so Deepak, you said that you have used linear regression. Is there
Yes.
any other algorithm that you have used for the experimentation purpose and comparison of the results with LR?
I have many other algorithms, but linear regression algorithm very few people's used in this case. So I choose this algorithm for detection linear regression algorithm and decreasing the energy consumption.
Okay, so as you said that there are other researchers also who have used this algorithm. So are your results better than the results of those who have already used it?
Yes, sir, my result is better than the other researchers. Many researchers, mostly in this case, use a linear regression algorithm used in a host overload detection.
Exactly. So that was
Yes.
going to be my next question actually. So how are you going to take care of host overload actually?
Because many researchers work on the host overload, but few peoples are work on the host underload. So I consider this uh, topic.
Yeah. So in fact, working for the dynamic detection of host underload is where you are contributing actually. Okay.
Yes.
Thanks Deepak for this nice presentation. We move on to the previous paper which Pratibha was not able to present. I'm not very sure whether she is audible now or not. Paper ID 134. Pratibha, can you please? Yeah.
Okay. Can I leave?
Yes, yes.
Yes.
Okay. Thank you, sir.
Thank you.
Actually, Pratibha has submitted. Okay.
So maybe Pratibha, you can log out and log in because she has unmuted, but I don't think that we are still able to listen to her.
Pratibha has submitted pre-recorded video.
Okay,
So I
okay,
think we need to play that video.
okay.
Just a minute.
So maybe Dr. Patel, can we just take into consideration those who are physically present here, and maybe at the end we will play her video.
Yes, that's a better idea.
Okay.
So
So
one
then
more paper is
we will,
paper.
yeah. So then we will go for paper ID 160 by Sukhvinder.
Yes. Okay. Sukhvinder, you can share your screen.
Yes, sir. Yes, sir. So my screen is visible?
Yes.
Your screen is visible, but the PPT is not. Yes, now PPT is there. Yes, yes. Please
Okay,
go
sir.
ahead.
Good afternoon, everyone. My name is Sukhwinder Singh Athawat, and I'm from NIT Kurukshetra. My paper title is Energy Efficient Task Scheduling in Fog Computing Environment using Topches method. So here is the overall agenda of my presentation, which will I covered in my presentation. As we move on the introduction part, with the increase of the IoT devices, the data is exponentially increases, which has to be analyzed and stored in cloud data centers. But due to the high data traffic and for minimizing the latency of the data, a new paradigm was came in picture, that is fog computing. So basically, fog computing is a decentralized infrastructure that plays storage and processing component at the edge of the cloud, where the data sources such as application users and sensor units. As we see in the figure also, fog layer is basically in the middle of the cloud and devices. So fog computing make the cloud services available through network and more accessible and closer to the user and end devices. Fog computing also lowers the traffic and delay. Beside that, we have some major issues with the fog computing devices, in which the first one is a fog server placement. In a fog server placement, to deliver the best services, fog server must be strategically placed in a right position. And the second one is security. Fog computing introduce additional points of vulnerabilities compared to the traditional cloud computing, with distributed resources and data processing at the network edge, and securing fog node and communication channel and data become crucial to ensuring the data privacy, access control, and encryption in the distributed heterogeneous fog environment poses a significant challenge. Next one is resource management and execution time and energy consumption and reliability. So my work is basically on the energy consumption factor, because as the fog node as compared to the cloud are resource constrained devices with limited energy resources, because most of them are battery operated, thus energy consumption become a crucial objective. So energy efficient task scheduling algorithm or techniques such as dynamic power management, task offloading, and task energy efficient task scheduling are required to optimize the energy consumption and extend the battery life of the fog devices. The optimization of energy uses also leads to the cost reduction and reduce the emission of the carbon dioxide. So here is the some of the work that has previously done in this field. The first one was performance and effective and low complexity task scheduling. The paper was basically published in 2008, but this is not considered the energy factor. And the next one is also not considered the energy factor. And the third paper is improved PSO and didn't consider the make span and energy. So we are trying to consider all these parameters in first. So as the volume of the data is increasing very rapidly for handling and processing the huge data, cloud computing is an emerging solution with an assistance of fog computing. So we have proposed an energy efficient task scheduling algorithm using a multi-criteria approach, that is a technique for order of preference by similarity of ideal solution, that is TOPSIS, with an primary aim to reduce the energy consumption, execution time, and cost. So as the task scheduling is an important strategy which helps to reduce the energy consumption in the fog servers. So for that we have considered a three-tier architecture. As in introduction, I show a figure in which we have a cloud layer at the topmost, and at the bottommost we have end devices, and in middle we have a fog layer. So the fog node receives the task from the end devices and schedule them based on the our consider factors like energy cost and execution time. So in the fog layer, there exists a fog administration that plays a crucial role in allocating the tasks efficiently. Our prime focus is on a fog layer in which the fog administration role is vital in achieving the energy efficiency. So here is the system model. In the fog, task can be modeled as T1, T2, T3 up to Tn, and we have the fog nodes, that is N, N1, N2 up to Nn. So we have calculated the energy consumption of these fog by a standard formula that is given in the slide, in which V is the voltage, F is the operating frequency, and A and C are the total capacitance as well as the switching activities per clock respectively. So for the execution time, we have used the formula that is length of the task upon the CPU rate of the processing, that the processing capabilities in MIPS. For the max span, that is the maximum of the total execution time, and cost is calculated with the given formula. So our prime motive is to reduce the energy consumption and make spend. So for that, we have to handle these three parameters simultaneously. We have used the concept of the weighted sum method, in which we have considered the three parameters, that is alpha, beta, and gamma. And the values of these alpha, beta, gamma is alpha we have considered 0.4 and beta 0.3 and gamma 0.3. Alpha 0.4 is because our prime objective is reduce the energy consumption. So this is overall my pseudo code, and I have didn't mention the standard TOPSIS code. So the TOPSIS accommodate the decision-making scenario involving the multiple criteria and provide the best potential solution. TOPSIS operates on the principle that the selective alternative should have the shortest distance to the positive ideal solution and the farthest distance from the negative ideal solution in a geometric sense. It utilizes the Euclidean distance to determine the relative proximity of an alternative to the optimal solution. The TOPSIS calculate the distance to the both the negative ideal solution and positive ideal solution by comparing these relative distance, and periodized order for the alternatives can be established. Due to its computational efficiency, simplicity, and compressive, as well as ability to gauge the relative performance of the decision alternatives, TOPSIS is widely employed in the decision-making processes. So TOPSIS include the various steps in which first one is we have to define a decision matrix. So in our case, we have defined a decision matrix of number of the available fog nodes and the criteria that we have considered, that energy, cost, and max span. So as we see in this code, we will firstly compute the value of these parameter and apply the TOPSIS method, and the TOPSIS method returns the scheduled scheduled length, and we execute the task on the provided the scheduled length. So for
yeah, I think we can proceed for the results, and maybe you can
yes,
compute within how many days.
So to benchmark the performance of the presented method, we compare it with the three existing algorithms, that is PSO, particle sound optimization, min-min, and min-max. And for executing the proposed approach, we have utilized the MATLAB software, which is a powerful system design and analysis software. In our study, we involve the assumption that every individual node possesses the different processing capabilities in MIPS, and having different voltage level and having different operating frequencies. And to check the performance of the proposed approach, we have considered the different number of tasks, that is 20, 50, and 100. And here is the graph for the energy consumption and energy consumption value and make span value. And here is the graph for the cost values, which we have get from our approach. And from these graphs, we can from these graph, we can clearly see that the value of our proposed approach is less as compared to already existing algorithms. So in conclusion, we have presented a task scheduling algorithm based on the uses of the TOPSIS, aiming to minimize the consumption of energy, cost, as well as make spend in the fog environment. And we have compared it with some of the meta-heuristic and heuristic algorithms, namely PSO, Min-Man, and Min-Max. And the results shows that the presented approach performed better in the term of minimizing the energy consumption, cost, and make spend. In future, we can extend our work by considering the other parameters, that is security. And in this approach, we have considered only the independent tasks. So in future, if we can consider it for dependent task also. Here is the some of the reference which I have used in the paper. Thank you.
Okay, thanks, Sukhvinder, for your presentation. As you very rightly said, particle swarm optimization, or PSO, as we abbreviate it, is one of the most commonly used algorithm as far as the energy efficiency task scheduling experimentations are concerned. Well, my suggestion will be to go for real world application, because sometimes when you are using the simulators or the tools, the results actually differ. So that is one
Yeah,
suggestion.
sir.
Yeah,
Yes, sir, I will consider it.
yeah, and the second, obviously, you can take into consideration the factors like latency and security. But in any case, you have already mentioned at least the security part in your future work, because I think it will be interesting to see the results varying when you are taking into consideration, instead of the lightweight protocols, the heavyweight protocols, which are making use of security as well as latency.
Yes, sir. For security, we are planning to focus on the data security part.
Great. Okay. Thanks for your presentation, Sukhvinder. We move on to the next presentation for paper ID 256, a load balanced task scheduling in fog cloud architecture, a machine learning approach. Paper ID 256, can you please raise your hand?
Actually, the author of paper ID 256 also submitted pre-recorded videos. And I think they are not present here. Author of 256 are they here? But author of this paper ID 134 is here. So we can run this pre-recorded video of paper ID 134.
Okay. Pratibha's video. Yeah.
Just a minute. Yes.
Morning, I am Pratibha, and first of all, I want to thank icSoftComp2023 for giving me opportunity to present my paper, having paper ID 134, and my paper named as Resource Management through Workload Prediction using Deep Learning in Fog Cloud Architecture. Okay, next. In overview, we will going to cover all these topics, includes introduction, proposed model, algorithm for prediction model, experimental setup and evaluation, conclusion and references. Okay, next we will move to introduction. With the growth of IoT devices, it will be very impossible for the IoT devices due to the limited resources to meet their requirements. For them, first we move to the cloud computing, but because of the unlimited resources, they can be able to execute all the IoT tasks uh, without any constraint. But the problem with the IoT is that key for real time problem with the real time task of the IoT is that they are not able to execute delay sensitive tasks on time due to their communication delay. For that, we move to the fog integrated cloud architecture. In case of the fog, those tasks, those are small and having very restricted delay constraint, we offload them directly to the fog, irrespective of irrespective to the cloud. Uh, However, the offloading of tasks to the most suitable computing server, decision making in the fog is a NP-hard problem. This research introduces a fog cloud specific workload prediction model based on the time, utilizing the intuitive fuzzy seaming clustering and long short-term memory technique, which is a deep learning technique, and we emphasis on the CPU and memory predictions. Our proposed model is based on the intuitive falsified seaming clustering and the LSTM to predict the future CPU and memory requirement of the IoT task. The model is a combination of both these techniques, which is help in better predictions of the future CPU and the memory uses, in which IFCM algorithm is used for clustering the similar resource utilization pattern, incorporating uncertainty and the flexibility of cluster assignment. The cluster representation is then fed with the LSTM as an input, which captures the temporal dependencies and the predict future resource workload. The combination of IFCM and LSTM leverages the strength of both the technique and resulting in improved prediction accuracy and the interpretability. LSTM captures temporal dependencies for accurate prediction, while IFCM provide through the membership and the non-membership values. Okay. Now I'm going to present the algorithm for resource prediction model. We designed the prediction model of resource occupancy of the fog node. For these, we must have input as a CPU occupancy data set and the number of intuitive fuzzy set and number of hidden layers. And by using these, we are going to predict the future uses of the resources. Okay. Uh, Actually, in this, we can see from the first step to fifth step to fourth step, we are going to calculate the membership value and the non-membership value. And after that, from fifth to eighth, we are going to merge these membership value and the non-membership value with the LSTM as the input. By using this, we are going to get more accurate predicted results. And experimental setup and evaluation. The proposed model is evaluated on real-time database. The database is collected from 1750 virtual machines hosted on distributed data center managed by BitBrain. The workload consists of two types of resource uses, CPU and memory uses. And in our model, 70% of data is used in the training phase and 30% is used in the testing phase. And for the evaluation of our model, we uses three parameters. First one is absolute percentage error, and second one is average absolute error, and third one is average square error. These three common matrices are used to evaluate our proposed model. And here we can see in the table the error values of the RMSE is 1.609 and the MA is 0.929 and MAP is 0.166. By seeing all these, we can say that minimum the values of these error, we can say that our model is uh, much accurate predicted the future value. In this graph, figure number 1A and B, we can see that the pattern of the data which is provided by the BitBrain database for the CPU uses and for the memory uses. And in next figure 2A and 2B represent the comparison between the actual data pattern and the test data prediction in both the cases of CPU and the memory. So the proposed work
I think Pratibha was, rather the video of Pratibha was in the last stage where she was about to conclude, but basically that was going to be the summary of what she already said. So Pratibha, are you here to answer the questions?
Yes,
Yeah.
sir, I am here.
Okay. So I just have two observations, rather suggestions. Number one, a lot of work has already been done as far as the workload prediction task is concerned, and that too using deep learning and the similar algorithms. So I was, just wondering, because it will be actually interesting to see the comparison of the results that you have received with the proposed algorithm with the existing ones. In fact, I have also reviewed and seen the publication of similar papers in 2023 itself, MDPI and Hindawi publications. In fact, I have also got two there. So my
Actually,
suggestion will be, yeah, so my suggestion will be to compare the results of your proposed algorithm with the existing ones. And when you do so, just make sure that you are using the same data set as was used by those research works, because then only, you will be in a position to compare the results. If you are using a different data set, then it will, there will be no fun in doing that.
okay. Sir, actually, most of the work are done by using LSTM only. I merged IFCM plus LSTM because I have concluded most of data are fuzzy. Because when we do clustering, a lot of data points are overlays between their clusters. So for that classification, after doing that classification, we will get more predicted result. Actually, this is my preliminary research. That's why I publish in this conference. After that, I am going to convert my this paper into journal form, where I will do extended work, like after prediction I will do offloading, I will optimize energy and delay, like that. I'm working on that.
Okay, and just also take care of the fact that you will have to use the same data set if you are comparing, because then only you will be in a position to say that these are the benchmark results or these are the baseline results. If you are using a different data set, then maybe you will end up comparing the results of your own algorithm with the results of your own algorithm only, which will not work actually.
Yeah, yes.
Okay.
Actually, my purpose is different. Actually, I thought of ki I extend my work to journal in another way. That's why I publish my half of work in conference, and then I will extend that.
No, but that is not an ethical practice. It is called slicing, research slicing. So that is not an ethical practice. Okay, so thanks for your presentation, Pratibha. We move on to the next presentation of this session for paper ID 256.
Just a minute, sir.
Yeah.
I am Rashmi Keshri and my paper ID is 256. I would like to thank icSoftComp2023 for giving me this opportunity to present my paper entitled A Load Balance Task Scheduling in
Dr. Patel, can you please increase the volume?
Using a machine learning
Yes, sir.
approach. So this is the overall overview of everything that we'll be covering in this presentation. First, I will start with a brief introduction, then state the problem and its formulation. Then I
So
will
these are
discuss the
maximum
proposed
volume.
approach that we have used in
Okay,
this
no
task
problem.
for task offloading and service placement. Then I will give a brief overview of all the experimental evaluation, and then we will have a conclusion. So without any further delay, let's start with the introduction. In the recent years, there has been a significant increase in the number of IoT devices and the requests that they have been sending to the cloud data centers, due to which there has been a huge congestion in the network and the cloud data centers. This results in delayed performance, which can be very crucial in certain cases where tasks are delay sensitive, such as healthcare applications and live streaming and online gaming and all those stuff. To relieve this, Cisco coined a new term named fog computing in 2011. It offers requests near to the request generating edge devices. But the problem with the fog nodes are their computation power are limited and they also have very poor battery life. So proper utilization of fog nodes is very important. The resources should be managed very properly. So in problem statement and formulation, we have MIoT devices that would be producing various number of tasks. Each task will have its own requirements, such as number of cores they require, uh, the CPU and memory requirements and all that, according to which we have to place it on one of the particular node. We have that node may be in either cloud layer or the fog layer. So first of all, we divide the problem into two phases. In the first phase, we decide on which layer we have to offload the task, whether the cloud layer or the fog layer. And in the second stage, we decide exactly on which node the task is to be placed, so that everything is properly optimized. So in the first phase, we used fuzzy C-means clustering for proper offloading of the task. Here we use an ML-based intelligent admission control manager that decides on the basis of delay sensitivity of the task that the particular task should be offloaded to the cloud layer or the fog layer. And in the second phase, if the task has been offloaded to the fog layer, we select a particular fog node that is best suited for that particular task. We will discuss that later. So this is the output of the first phase, that where we used fuzzy C-means clustering to form the three cluster of the task. Here we can see we have magenta color tasks that are non-real time tasks that have been offloaded to the cloud data center. In addition, the next two, we have the green colored tasks that are important tasks, and the yellow colored tasks that are real time tasks. For them, they are extremely delay sensitive tasks, and they must be offloaded to the fog node for uh, for fast response. In the second phase, we apply k-means algorithm, k-means clustering algorithm to form 4 clusters of the task. Each task is either marked CPU intensive, memory intensive, both CPU and memory intensive, or none based on the cluster it belongs to. Similarly, each of the fog host is also classified as CPU overloaded, memory overloaded, both CPU and memory overloaded, or CPU and memory underloaded based on its current resource availability. At the last, a task allocation algorithm maps all the CPU intensive tasks to memory overloaded hosts and memory intensive tasks to CPU overloaded nodes. Both CPU and memory intensive tasks are assigned to CPU and memory underloaded nodes. This leads to appropriate load balancing and minimum resource wastage. So here we can see the task clustering that has been done using k-mean algorithm. The y-axis indicates the memory usage of the task, and the x-axis determines the CPU usage of the task. And we have all the four groups that we talked about. Here we can see the classification of host. The host can be either CPU overloaded, memory overloaded, or both CPU and memory overloaded, or both CPU and memory underloaded. And all the tasks are mapped to their respective host that they can be offloaded to. Next, we have experimental evaluation. We have used the data set from large hydroid chloride, and we compared our approach with various other approaches such as RLFS, LBSSA, DRAM, GA, and PSO-GA in the terms of load balance variance, average response time, number of devices used, and execution time that has been taken by our algorithm. Overall, overall, after seeing the result, we can conclude that our proposed method performs better than all the other approaches that we have considered. So we can say our method is quite effective. As conclusion, I would like to say that we have applied machine learning model that has been proposed to attain proper load balancing in task scheduling, and we have considered various parameters. We worked in two phases. In the first phase, we decided an offloading layer where our task would be offloaded whether to a fog layer or the cloud layer. Then in the second phase, all the tasks that were offloaded to the fog layer were properly mapped on the best node possible to attain the best performance on behalf of certain parameters that we have considered. And these are all the references that I have used. Thank you.
Okay, so I don't think the last presenter is available here to answer the questions. So we will conclude this session with permission of Dr. Patel. So in total, we had 5 papers presented in this session, out of which 2 were video presentations. And the theme of the presentations was revolving around the fog cloud architecture, mostly dealing with task scheduling and load balancing. In fact, something that just crossed my mind after going through all of these 5 presentations was the possibility, if at all, all the authors of these 5 papers may collaborate, because more or less they are working in the similar areas. So, when someone is talking about task scheduling, which is energy efficient, and some other paper is talking about a load balanced task scheduling. So it will be really interesting to see if they can come out with a combination of both of these concepts. Thanks, Dr. Patel, for inviting me. Over to you. Thank you.
Thank you, Dr. Saini, for sparing your valuable time to chair the session. Thank you very much. Okay. So now it's time for a break. So we have a break from 1 to 1:30. Okay, bye. We'll come again at 1:30 IST for technical session as 3.